All right. The prom committee is trying to decide.
How much you must charge prom?
The prom committee is trying to decide.
How much to charge prom tickets?
They know that the total cost of the DJ, the venue, and the decorations will be
$2,000.
that was the end of the sentence. Okay. Also, each person's food.
Will cost $15.
How much should they charge?
Per ticket.
So what do we not know?
How many people are attending?
How many people are attending? And if we don't know the people attending, then we don't know the cost of the ticket, right? All right. So then let's think this through. We want to figure it out. First of all, let's start with 0 students. So if you're going to tell me that the cost of the ticket is $0, then you're assuming that the tickets are free.
No.
So you're telling me if You're telling me if 0 people go, the tickets are free.
No, but you're not going to charge $15 if 0 people are going.
Exactly. Are you going to charge money if nobody goes?
No.
No. So then are you going to have a ticket price?
No.
Then what do you call that if there's no such ticket price? Error. It is undefined for this situation. You have to have a minimum of at least 1 person in order to charge a ticket price. Because tickets are for people. Yes?
Yeah.
Okay, so then let's figure out how much I would charge for 1 person attending.
$15.
Before you assume, let's go back to the problem. Let's go back to the problem. What were the total things in here that involved money?
The cost of the DJ, the
Was-
decoration was $2,000.
Yeah, we had a total of $2,000. Can we change that?
No.
All right, so then we know we're going to start with the cost of $2,000. Okay, does it stay at just $2,000? What else is being a part of this cost?
The food.
The food, but the food is not just set 15, it's 15 per person. So then I'm going to add how much money to 2,000 if it's 1 person? Plus 15. Right? For 1 person. Everybody agree?
Yeah.
So then how much is this 1 person's ticket going to be? $2,015. Because do you have any other people attending to split it among?
No.
Then that person is $2,015. Yes, I understand. This is not realistic. Obviously, if it's going to be that much money, would you even hold the prom? No. But in math, we're still going to collect data for the what ifs. This is all it is. We're doing the what ifs. If 1 person came, that's how much it'd be. All right. So what would I change if 10 people came? Would it still be a total cost of $2,015? No, the cost is going to change still, though. So we'll get to that. But the cost is going to change. Why? Because what in here is changing if more people go? The food. The food is $15 per person. So if 10 people go, that means it's $15 times what? 10. But then is it going to be that amount? Figure out how much the total cost is now. Put it in your calculator. 2,000 plus 15 times 10. How much is your total cost? $2,150. Are you going to say that each of the tickets then are $2,150? What are you going to do to that? You're going to divide it by the number of people. You split it evenly. So divide it by how many people? How much money is that per ticket? Huh?
No, 2015.
It should be $215. Did you put? Oh, you're good. Okay, so then is this going to change at all, this setup that we have here for if there were 50 people? It's going to be the same setup, except instead of putting 10, we're going to put 50. So go ahead and plug in 50 now. 2,000 plus 15 times 50 people would be how much total cost?
It would be
How much? Okay, then divide that by how many people attending?
2015.
Divided by how many people attending? 50 is how much? $55? All right. Now do 100. By the way, there's more than 3 people that have calculators.
Now, $2.15 for a ticket. I don't know. I think I might buy it.
Oh, so I'm not grabbing this.
What was going up when she's on top out?
The what?
Like, what says 2,000 plus 15, and then what was going to do again?
Well, it's $15 per what?
Oh, versus
So then how many people are going?
100, so
Then 100 goes there, and then you're going to divide it among how many people total? 100 again. Because you're splitting it, even though it's per person, there's 100 people, but you're splitting the total cost among those same amount of people.
That's why I messed up the second one.
You put different numbers?
Yeah, I got it flip.
Yeah, these should be the same then, because they're still the same people attending. Okay, so what'd y'all get for 100? 35. We sure?
Yes, that's what I got.
Okay, for 200?
Okay, like,
25? Got 25? Y'all better not be saying yes when you didn't do it, because I'm just writing these down. I'm not doing it.
I did it.
All right, what about 1,000?
I don't know. I got 17.
17? Got 2 17s. All right, we got another 17. Okay, so then could this keep going? Yes, if more people come. Just because I stopped the table doesn't mean we can't keep going. My question is, what do you think it's going to approach? So $0 is what it's going to approach.
No, and it's
Your first system is keep.
How much? If it's 2,000 that we're splitting evenly, then maybe. But it's not just 2,000. What does each person have to pay?
$15.
So what do you think the bare minimum would be?
$15.
$15. Because you can't split that up. If everybody is required to pay 15, then that's going to be the bare minimum, is spending 15. How could we have figured that out by using characteristics we did in class? What your outputs approach. What does that sound like? Your horizontal asymptote. So right here, we're going to put the letter N, right? Because that represented the number of people. How could I find the HA? Well, let's see. The degree rules. The degree in the numerator, what's the highest exponent? 1. What's the degree in the denominator? 1, which means divide the coefficients. So what's the coefficient here? 15 divided by 1 is how much? There you go. You proved it. It will approach $15. Okay, so what happens to the ticket price as the number of people increases? It decreases and approaches what? 15.
Hit with that K. Zip.
All right, questions on this one? Okay, can we do one similar?
Nope.
On back.
Wait, hold on. I'm almost done with this quiz, but I feel like I'm doing good on it. I need your help. You ready?
No, not right now. We're doing this for now.
I'm finna turn in a little bit. Wait.
Okay, go ahead, flip it. We're gonna ignore the lemonade problem. Not a good problem. Just, it's not. But this one's better. Alright, read along. Everybody should be on the back side. You are planning a party. The location you rent.
Cost $300.
The location you rent.
Cost $300.
The location you rent.
Cost $300.
Thank you. The food.
Cost $10 per person.
Alright. There are 20 special guests.
Who will not need to pay, but they need to eat.
So there are 20 special guests who will. So they're still eating, but they don't need to pay for their food. Right? So basically they're free. They're free. Okay, keep going. But the cost will be divided evenly among the.
Remaining guests.
What do we mean by remaining guests then?
The people who are not the special guests.
The people who are not the special ones. Okay, so we want to know what is the cost per guest. Obviously the ones that are paying, not the special ones, right? Okay, so instead of us filling in the table first, let's try creating the equation first. What is the total cost? We always start with cost, right?
300.
So what's the cost right away? 300, because that's the fixed amount. That's $300 for the rent. Is 300 the only amount that it stays at?
No, plus dude.
It's also adding $10 for the food. But does it stay as just plus 10 consistently?
No.
What changes that?
The 20 guys.
Just the 20 guests? Isn't it still $10 for every guest?
It's the people.
So does it matter whether the guest was free or not?
No.
You still have to pay for their food, right?
Yes.
So $10 per person. What do I put here?
Oh,
Parentheses.
a single person and one person.
It's only one person? So you're only going to pay for one person's food. Do you know how many people?
No, so it's
We're going to put a variable X to represent $10 per however many people are going to come. Okay, but here's the trick. Can I just divide by all the people?
yes.
Because everybody is paying evenly that shows up.
No, you have to take out.
Who is not paying?
You have to take out 20.
We got to take out the 20 guests. So how do I say take out the 20? Subtract 20 from it. Does that make sense? You're still dividing it amongst the people, but minus the 20 specials. Any questions on how we set up the equation?
Nah.
What?
What if I put the 20 minus it?
Then that would say you're dividing it by 20 minus all the people. So what if there's more people that show up other than special? Can you divide by negative?
No.
You'd have to start with the total people minus the 20 from it. Does that make sense?
No.
All right, so then my question is, what is the bare minimum of people that need to come in order to have somebody paid for the party?
20.
So what's 20 minus 20? Can we divide by 0?
It'd be 21. It'd be 21.
Why do we need 21?
Because you need that one
You need that
person.
one person.
You need that one person to pay for everything. Because 20 of them are free. That does suck. But we do the what ifs, remember? Okay, so then let's start off with 25. By the way, are we going to keep plugging each of these in like you did on the last one? What's a faster way?
Finding your horizontal aspect. Was it just?
Did you hear my question?
No, I didn't.
Okay. Well, why are you answering if you didn't even know what I asked?
I thought I
Yes.
heard the question.
Yes, put it in the y equals, guys.
Oh, I didn't even hear what.
Put it in y equals. It's a lot faster. My calculator's dead.
Wait a minute.
You a math teacher, but your calculator.
I should get a shirt like that, right?
Oh, that's cute.
Okay, go to y equals. It's a lot faster to plug in x's to find the y's if you just look at the table. Okay, so numerator, 300. I know my voice keeps cracking. My throat is like not working with me today. It's like dry, but not dry. X minus 20. There we go. Okay, so now go to the table. Now, probably not where I want to start. What did we say the bare minimum of people had to be? 21, right? Do you remember how to change your table to starting at 21 so you don't have to sit here scrolling? Hi, y'all need to listen. Where does it say table set?
Window.
Where are the windows? So hit the blue button, hit table set. Where do you want to start? Table start.
21.
21. Now go back to table. Bam. 21.
Okay, so do that again.
I could have already been there scrolling.
All right. So go to 25. How much money for 25 people? 110. Which means there was really 5 people paying, right? Because 20 of them were special. So each of those 5 people paid 110. Now go to 30. I don't want to scroll, but I will. How much? 60. Now go to 40. Now go to 50. So what happens at banks? Do you ever see that amount in your bank account? Do you know what banks do whenever money looks like that? They round it up to the hundredths place, just like money. So then look at the 7. What is the 7 going to do to the 6? Make it up. Make it go up 1. So then this is going to be $26.67. 67 cents. Any question on that? Okay, so let's put 26.67. Okay, go to 80. What's it going to be? Go to 80. What's it going to be? Say it again, one more time.
$18.30.
Yep, $18.33. Go to 100.
And 33.
By the way, you can use a table set thing. It's kind of faster. 1625. And 200. Use table set. It's a lot faster instead of scrolling.
45.
$12 and close. 78 cents. $12.78. Okay, so then let's figure out, what do you think the cost is approaching? I'll give you a hint. Use your degree rules. Why 10? The food is going to cost $10 per person, so you're still going to approach the tit. And if you looked in your calculator, if you sit here scrolling for forever and ever and ever, I can go to 1,000 people. Look, let's see what it says at 1,000. Look how close it is to 10 now. $10.51. And I could go even further. We're going to get even closer to 10. But will we ever get to it? No. All right, so let's go ahead and graph, and then we'll call it quits right here. Do you guys know how to scale a grid? So that way you can put as many coordinates on here to get a correct image. Yeah, exactly. So how many tick marks are on the x-axis? Count how many tick marks. That means more than 4 people. Lucas, what did I ask y'all to do right now? No. Pay attention, please. Romeo, what did I ask you to do right now? He doesn't know either. What did I ask y'all to do? I said count how many tick marks there were. How many tick marks are on the x-axis? The tick mark. This is a tick mark. 1. There's 12. Okay. What is the largest x value we have in our table that we want to use?
25.
That's the largest.
200. Sorry.
Okay. So then divide 200 by 12 in your calculator. Do 200 divided by 12. What is it? Okay, so then maybe we could count by 15s or we could count by 20s. Something around that number is how you can scale your x-axis. Okay, then let's go by 20s. But do y'all see how I was trying to figure out a number to spread it out? Okay. Okay, 20, 40, skip 1, 60, skip 1, 80. Oh, dang it. 100. Skip 1, 120, 140, skip 1, 160, 180, skip 1. There we go. I was just putting the 20s in between by skipping, so that way. Did I? No, I didn't. It's in between.
Oh, it's in between.
That's why I said I was skipping one. I'm still putting it there, but I'm not writing it, so that way I have space. You know what I mean? So that we can actually see the numbers. Okay, let's do the same thing for the y-axis. How many tick marks are on the y-axis? How many tick marks are on the y-axis? There you go. There you're good. 110 is the largest, which we will use. But how many tick marks do we have to use?
12.
12 again? Okay, so what's 12 divided by 110? I said it backwards. 110 divided by 12. You know what I meant. So then what's good? Go by 10s. 10. Skip it. 20. 30. Skip it. 40. 50. Skip it. 60. 70. Skip it. 80. 90. Skip it. 100. 110, and so on. All right, now we can graph it to where we'll actually see our coordinates show up. And it won't look like a straight line or something crazy. It'll look like how it's supposed to. All right. What is going on the y-axis, by the way? What represents our y-axis? The what? What's the outputs? Cost per guess. Let's label the outputs cost. What goes on the x-axis? Number of x-axis. All right. Everybody caught up? Can we start graphing?
Hell no.
Okay.
Hold on. Can you freeze it? So I can write it up?
I'm still doing it, so it's up there.
Alright, bet.
All right, so let's start with 25. If 25 guests show up, so here's 20, 25 is a little bit after, we have how much costs per guest? 110, so go up to 110, way up here. There we go. 25 guests, $110 per guest. Okay, now we go to 30. For 30 guests, it's 60. So 30 is halfway in between here. We're going to go all the way up to 60.
In the middle.
Yeah, sorry, I almost went past it. They look pretty close to each other, I get it. That's because we're dealing with big numbers.
Okay.
Okay, next one is, if 40 guests go, then we have $35. So go to 40, and 35 is in between here. Y'all see the curve happening?
Yeah, slowly but surely.
All right, 50 guests is about $27 almost. So go to 50.
Oh, we going by like, okay, I see.
The x-axis is going by 20s. The y-axis we said was going by 10s.
25 is actually, oh, 25, 30, 60.
What did we say? $27.
What is it going by? The bottom going by?
20s. Okay, 80 guests is about $18. So go to 80. What did I say? $18, my bad.
18 euro.
So a little bit below the 20. And then 100 guests is about $16. So 100 guests, 16. Almost halfway. Do we see how it's starting to approach that
Yeah.
$10 line?
Yeah.
Okay, keep going. 200 guests is $12.78. So all the way over here, 200. Even closer to the 10. So you see that piece of the rational function showing up, right?
Yeah.
It's going to approach that asymptote. What was our vertical asymptote? Make note of that. What makes the denominator 0 here? 20. X equals 20. Oh, well look here. Does it look like they were hugging 20? Yes, it does. What is our horizontal asymptote we already made note of? 10. Does it look like it's hugging the 10? Yes, it does. My question, can I connect these?
No.
Why not?
Because it's not a,
Can I have half a person?
No.
Then can I connect these dots and say what's in between everything exists? Leave it discrete. Leave it discrete. Discrete means you have just the coordinates that show up. You cannot have half a person. So there's your graph. It will continue going this way though. It approaches 10. Okay, so I'm gonna pause here. It may seem like a lot, guys, but it really was